Okay, so integration by substitution. All good? Yep, no issues? Okay, so what about something like this? What if I wanted to integrate sine x with respect to x? How would I do that? Not a bad guess. Have a think. Didn't we say that integration is just the reverse of differentiation? Yeah? So if you remember, when we were doing derivatives of trigonometric functions, what's the derivative of sine x? Cosine x. What's the derivative of cosine x?
Minus sine x.
What's the derivative of negative sine x?
Minus sine x.
And what's the derivative of negative cos x? Sine x, okay? So, this is for derivatives. Surely with integrals, we just go back the other way. Because derivatives and integrals, they're opposites of each other, aren't they? Differentiation, integration, opposites, yeah? So in other words, if we're at sine x, we're here, we should go back the other way. In other words, go anti-clockwise to find the integral. So what I'm proposing is that the integral of sine x should be negative cos x. Plus c, obviously, because we've still got that plus c there. Yeah? Does that make sense?
Yes.
Yeah? What about something like this? Oops. What about something like this? Why? It's the same idea, yeah? This idea here is called the antiderivative. Anti meaning the opposite, right? So it's the opposite of a derivative. So if you know what the derivative is, you can kind of cheat and go back the other way. It's almost like you know the answer, so it's giving you the answer, what's the question? Yeah, to the differentiation. So because you know that this thing must be something differentiated, you can just go back the other way. Does that make sense? Yeah? Okay, so can you have a go at questions? Sorry, I haven't unpaused the screen. Can you have a go at the... Yeah, why not? Let's have a go at questions 1, 2, and have a go at 3 as well. What do we get for the first one?
Minus cos x plus e over x.
Perfect. Yeah? Plus?
C.
Plus c. Good. Have a look at the next one. So let's just think about this. The integral of cos of 4x plus 5 with respect to x. Now, are you happy you could do this actually by substitution? Yeah? You can let u equal that, then differentiate that, and then find dx, and then make a substitution, then work it through from there. But actually, we can speed the process up just a little bit. You happy? Because if I think about it, I know that this is the result of differentiating some function. Okay? It's the result of differentiating some function. So what would ordinarily the derivative of, what the integral of cos x be? Yeah, good. Sine x. So I'm expecting my original function, in other words, the function that I differentiate to get this, to be sine of something, okay? Sine of something, obviously plus c, okay? Now, are you happy that if I take sine of maybe 4x plus 5, just think about the chain rule, okay? I differentiate this, I get cos. I differentiate this, and this should stay the same, yeah? So chain rule, differentiate this, you get cos, and then the function inside stays the same. However, if I was going to differentiate this, what would I get? So I get cos of 4x plus 5 times by 4, times by the derivative of the inside function. Literally think about your chain rule, right? You differentiate this, you get cos, okay? You differentiate this, you get your 4, the derivative of the inside function. I haven't got a 4 there though, have I? So strictly speaking, this is not the derivative of that, okay? But I can make it the derivative of that by using my fudge factor. I want a 4 there, then that would be the derivative of that. But I can't just stick a 4 in there wherever I like, can I? Can I? So I've got to get rid of it. I can get rid of it by dividing by 4 out the front. You happy that this is still the same thing as cos of 4x plus 5? Yeah? It's just, I've thought about where I've come from. I've said, well, it's got to be sine of 4x plus 5. But if it was sine of 4x plus 5, I'd have to have a 4 here. I don't, but I can easily stick it in. Yeah? Just by thinking about 4 and then dividing by 4. 4 and then dividing by 4.
Yeah.
Is that okay? So in other words, this is now the same as this, but I've just got to make sure I bring along my factor, my quarter, my fudge factor. Does that make sense?
Yeah.
Because think about it, this thing here, if I differentiate it, I get this thing here, okay? Now you remember, it only works because I've got the 4 there. I've got the 4 there. In other words, I'm going to have to put my fudge factor in. I've got to divide by 4. Yeah? And hence, because I've divided by 4, it still comes along for the ride. Is that okay? Good. Have a look at the next one then, or have a look at the same question actually. So we've got the integral of e to the 7x plus 5. Is it 7x plus 5? Yeah. Yep, 7x plus 5. Minus 5? Doesn't really matter. Okay, there you go. Okay. Integral of 7x, e to the 7x minus 5. Okay. Now have a think. I'm expecting the original function, in other words, the function that I differentiate to get this, to be e to the power of 7x minus 5, aren't I? 7x minus 5. Okay. Because it's just simply the chain rule. Yeah. However, if this was e to the 7x minus 5, I'll put the plus c in as well. If this was e to the 7x minus 5 and I differentiate it, what do I get? What do you reckon? Yeah, I'd have to put the 7 down here. I'd have to put the derivative of this thing here. So let's put it in. So I'm going to put the 7 there. However, I can't just stick 7s wherever I like in my function. I've got to make sure that I haven't changed the function at all. There I get a 7th out the front. And of course, that means that I get 7th down here. Is that okay? So actually, the derivative of that, sorry, the integral of that will just be that. Now, if you don't follow that, that's fine. Then just make u equal that and just go through the integration by substitution. But I'm just showing you a slightly quicker way of doing things, okay? Think about the chain rule, then just think, well, actually, I need a 7 there. To get rid of that 7, I need to divide by 7 as well. Is that okay? Right? So as an example then, what about the next one? Actually, we'll come back to that one. What about this one? Okay, what about the integral of sine of 4x minus 3 with respect to x? Okay, what would this one be? Good, because I'm expecting sine to come from where? Cosine, so it's going to be cos of 4x minus 3. Remember that function wouldn't change, okay? However, if this was going to work, I would need a 4 there, right? Can't just stick 4s wherever I like in my function, though. I've got to make sure I divide by 4 to make sure that those two things cancel out. Hence, I've got to have the 4, the quarter over there. Yes? Bottom. Is that okay? Does that sort of logic make sense? Like I said, it doesn't matter too much. If it doesn't make sense, just let u equal that and then just follow your integration by substitution. But sometimes it's slightly easier just to do it in one line. With practice, it becomes slightly easier. Is that okay? Good. Excellent. That's it. That's it. Okay. So I've shown you how you can do integration by substitution in one line if you think about it. Okay. If you don't like that, just use integration by substitution. It will always fall. Is that okay? Okay. Can I ask you to have a look at? Okay. Can I ask you to have a look at the sec squared one? So. Was anybody copying that? Sorry, it's gone now. It's on the camera, it's fine. The integral of sec squared of 4x with respect to x. Okay? Okay, how could we do this one? How could we do this one?
Which one?
This one. So think about the question I'm asking here. What function, when I differentiate it, gives me sec squared? Tan. Do you remember that's one of the ones I got you to do? I got you to differentiate tan x. Yeah? And that gives me my sec squared x. Okay? So I'm expecting the original function after I before I differentiated it to be tan of something. Okay? Tan of what? 4x, good. Okay. However, if I differentiate this thing, do I get this? No. What do I get? Yeah, I get 4 sec squared of 4x if I differentiate this thing. Yeah? I can't just stick a 4 in there wherever I like, though, so I've got to divide by 4 as well. Hence, I've got to put my fudge factor in. Is that okay?